So let's say you've got two objects and you want to rotate one of them by the other one's rotation. In other words, as in this case the tracker rotates, we want our little dial thing to rotate the same way. Well, this is pretty simple if the rotations are both zeroed out initially. If I hit play right here and I grab our tracker and I rotate it, I have a script that's basically going to rotate these two together. This is an easy thing to do. You can basically say set the rotation of the second object to the rotation of the first object. Then when the tracker moves, the dial rotation is the same. Easy peasy. But if the initial rotation of both of these is not zero, this is a much more complicated problem. And you quickly learn that you can't just set the rotation of one to the other. So here's how we're going to solve that. And to show you that this works, what I've done is I've got these two transform arrows that are basically going to be set to the zero rotation. And then we're going to rotate these other things just randomly. So this one's rotated way the heck over here, and this tracker we're going to rotate it way the heck over here. Okay? So now I'm going to put the tracker transform arrows back in and hit play. And now if I rotate this tracker, if you watch the arrows, you'll notice that they do actually rotate the same way. So there's the tracker, there's the rotation there, there, and there you go. So it is rotating the same way, even though the initial rotations are different. And here's how that works. We have two objects. We have a control object and a target object. We have an offset rotation that we're going to use, and we have an initial target rotation. The offset rotation is the inverse of the control object's rotation. In other words, this object right here, the inverse rotation of this, is going to get us our offset rotation. This is kind of like taking the negative distance of something. And then the initial target rotation is going to be this target rotation right here as it currently stands, which in this case is going to be -24, 106, 183 on those axes. So every update, what we want to do is we want to take our control object, which is this tracker, and we want to multiply that by the initial offset rotation that we calculated up here. We stored that, and that is going to give us the first half of our number. So that's going to give us a rotation that basically is you can think of this kind of as a reset for the initial rotation. And then we want to multiply that reset by the initial target rotation that we stored up here, and that's going to get us our final rotation. And that's how that works. And we can actually simplify this using a little bit of, simplification. And we can come up with this. At the outset, what we want to do is we want to take our initial control object rotation, get the inverse of that, just like we did before. This time we want to multiply that by the target object's initial rotation. Okay? So we're basically combining these two steps, the offset rotation and the initial target rotation, so that later we don't have to re-multiply our rotation by the initial target rotation. This is all stored in the offset. So now all we have to do later is we take our control object rotation and multiply that by the offset rotation, and that gets us our final rotation. So let's look at that one more time. If I rotate this, you can see by the arrows that it is rotating the other one the same way. That's all there is to it. So again, I have to stress, this is the inverse of the control object's rotation multiplied by the target object's initial rotation. That's what you get. That's how you get the offset. And then you can multiply that control object rotation by the offset later to calculate the new target object rotation.